So when we're trying to go between a growth factor and a growth rate, that means we're going between the value that you would multiply a number by in an exponential growth pattern to a percentage change that's achieved by multiplying by that growth factor. So with all of these, because percents involve out of 100, that's what percent means. For all of these, I always think of like a hypothetical, like a $100 that's changing by a certain percent or being multiplied by a certain growth factor. So starting with this first one, with 0%, if something changes by 0%, that means it's holding steady. It's not going up, it's not going down in value, it's just holding steady. And so the thing that you would multiply something by in order for it to not change at all would be 1. So for this one, the growth factor is equal to 1. Okay, and again, that might seem kind of weird. You might think, well, you multiply it by 0, but remember, if you multiply something by 0, it goes from whatever its value is to 0. It would lose 100% of its value. It's only changing by 0%. It's not changing at all. You're multiplying it by something that preserves its value, which would be 1. Now, if something changes by 15%, so think of that hypothetical $100, and it goes up by 15%. That means it goes up by $15. So you're going from hypothetically $100 to $115. For your growth factor, you're thinking, what would I multiply 100 by to get 115? You'd multiply it by 1.15. And you could get that just by dividing 115 by 100. Remember, that's like dividing a y value by its previous y value. 115 divided by 100 gives you 1.15. And as you go through these, you'll start to notice a pattern relating a growth factor and a growth rate, which is what the last question asks about. So if something changes by 30%, so it increases by 30%, that would be your $100 going from 100 to 130. You would multiply that by 1.3. For 75%, you would multiply by 1.75. 100%, this is another one that 100% and 150%, they're both a little bit weird. So you have to think, if my $100 increased by 100%, so that basically it increases by its entire value, it would go up by another $100. So you have $200. And 200 divided by 100, that's a growth factor of 2. So when you multiply something by 2, it goes up by 100%. For this one, something goes up by 150%. That means your $100 would go up by $150. You would now have $250. The multiplier that would achieve that would be 2.5. So like I said, it's really tempting to just think that you're going to turn that percentage into its decimal equivalent to get your growth factor, the multiplier, but that's not the case. You want to make sure that when you are going from a percentage to a multiplier, you want to make sure what you're multiplying by actually achieves the amount of growth indicated by the percent, which is why I used the example of $100. So there are a couple ways you could describe doing this, like what the algorithm is for going from a growth rate to a growth factor. But I like to think of this as I am turning my percent into a decimal. But we're not done there. So if you turn your percent into a decimal and then multiply your hypothetical starting amount of $100 by that, you're not going to end up with that percent increase, because most of these are, when you turn them into a decimal, less than 1, so they'd actually make the value go down. And so what you're doing is you're turning the percent into a decimal, then adding 1 to it. So when you're adding 1, think of it this way. If you have something that's worth $100 and it goes up by, let's say, 15% to $115, when you're adding 1, Basically, that means like 1 in percent form is 100%. And so adding 1 means you're including 100%, which is 1 in decimal form. You're including 100% of the starting value or the previous value in the new value with a percent increase. So if something increases in value by 15%, the new amount that I have is 115% of what I previously had. And 115% as a decimal would be 1.15. So I'm referring to this one up here. So even if the problem that you were working on involving a growth rate and a growth factor wasn't $100, the value still works the same. I'm just using $100 because it's easy to do work with percents when you're thinking of 100, and it just helps you think through the problems. So in the next set D, we're just going the other way. We're going from the growth factor to the growth rate. So we want to get the percent. And again, I'm going to use that example $100. So you want to think, if I took on this first one, so the growth factor of 1.5, I want to know what the growth rate is. Growth rate just means what percent is it going up by when I multiply a value by that growth factor. So if I have $100 and I multiply it by 1.5, I now have $150. So that's an increase of $50 out of $100. So my $100 went up by 50, which equals 0.5 or 50%. So for this one, a growth factor of 1.5, a growth rate of 50%. Multiply something by 1.5, that something increases by 50%. And again, you might notice a pattern as you do these. So if I took that 100 and for the second problem, I multiplied it by 1.25, my $100 would turn into $125. So if my $100 goes up by $25, it's going up by 25%. 1.1, if you multiply something by 1.1, it goes up by 10%. If I multiply something by 1.05, so if I take my $100 and I multiply it by 1.05, I now have $105. So if it goes up by $5 out of 100, that's 5%. And then these two, like in the other set, there's a couple weird ones. You have to think, if I took my $100 and multiplied by 2 to get $200, that's an increase of $100. So my $100 increased by $100. That would be a 100% increase. My $100 increased by itself entirely. It doubled. So when something doubles, it's increasing by 100%. You're adding that thing to itself, and it doubles. Likewise, if I multiply something by 1, it doesn't change. If I take $100 and I multiply it by 1, it's still $100. It's changed by $0, which is 0%. So now this isn't the only way to think of this though, but the general algorithm for going between a growth factor and a growth rate is we're taking that growth factor and we're basically doing what we did in part C in reverse, where we turned it into a percent, turned the percent into a decimal and added 1 to go from a percent to a factor. I'm going to just do that in reverse. Take that growth factor, subtract 1, then turn into a decimal.